This is one of our last 2 Mondays of the school year. Since next Monday you will not be here, and the one after that will be the last one, ladies and gentlemen. We are starting to get down there. All right. Today, ladies and gentlemen, we got an activity that we're going to do in the lab about redox. And we're going to give you this to start out with. So grab a pencil and your periodic table, ladies and gentlemen.
Oh, I did too yesterday.
Because I really didn't understand.
Please pass it back, yes.
I really didn't understand that. Because it's difficult to understand that.
Understand to take out a pencil and your periodic table?
Last week, I was confused.
Well, we are not done with it yet, so don't panic.
Because I was confused.
I get some
Well, we did last week, I was confused.
Okay, well, we'll try to unconfuse you today. Oh. All right.
What the fuck is that?
So these are 4 chemical reactions. Last week, we started looking at chemical reactions, and we started to write down what the charges were on each side so we could try to recognize reduction and oxidation. Now, please remember, this goes back to using the periodic table, ladies and gentlemen, and the charges that are written below or above each family. So what I would like you to do is in here, or on this sheet, above the element and after it. So like in this area up here, you are going to take and you are going to write down what charge each of these things has. So in this area, oops, sorry, I got to bring this over. Right up here. Hang on a second. So right in here, you're going to write what the charges of these things are above and after them. Now, please remember, if something is alone, not with anything else, what's its charge? What is the charge of a lone element? Right? Neutral, 0, no charge. So if something is alone, if it's not combined with something, it's automatically 0. So go through and find the things that aren't combined with something and put a 0 by them. Then when they are with something, we need to find the charge of both the non-metal and the metal so that they total out to be 0. But again, most of these you can look at the periodic table and find their charges. So go ahead and take a couple minutes, ladies and gentlemen, and list all of the charges of the different elements that are on here for us, please.
Mr. Brad,
Yes.
can I take the quiz tomorrow after school?
Why?
Because I didn't do it on Friday.
Yeah, we can go do it right now.
I don't want to do it.
Why not?
Oh, great.
Why not?
I don't know because I'm not.
Ah.
Okay. But if you don't come tomorrow after school, we're doing it on Wednesday in class. And I will not give you an extension again. Okay? So that's fine. We'll work through it. Okay? All right. Helen, you ready for yours? Tomorrow during class? Certainly. Not a problem. All right. Dun, 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 dun. Not here. Not here. Here. Here.
It just was so different. I think I'm like cartoon.
Go. you're telling me what the charges are. So, for us to identify redox, again, ladies and gentlemen, we need to know how the charge is changing from one side of the reaction to the other. So what I'm asking you to do is go through right now. Lone elements always have a charge of 0. So if they are a lone element, you're going to put a 0 by them. If they are in a compound, you go to the periodic table and find the charge based on the family that it is in. And list all of the charges. So anytime something is in a compound, it should have a charge by it. You should be able to find all of the charges of everything on here, ladies and gentlemen. So again, take a couple minutes and get that done while I am finishing getting attendance and a couple of other things. Well, that's why we'll go over it, Zoe.
Each of us have the same one.
Yep. What? Number 35 on your periodic table.
Thank you.
You're welcome.
It should be with your on the other side of the staircase.
Well, she'll find it. Once we give her where 35 is, she should be able to find it fairly easily. But when you say the other side, which is the other side?
The other side.
It's toward the right-hand side. You are correct, Zoe. Yep. Again, ladies and gentlemen, one of the things that you're going to be expected to do on your test and on your final exam is figure out which substance is oxidized and which one is reduced in a reaction like this. And if you can't find the charges, there's no way you're going to be able to figure out which one is oxidized and which one is reduced. So a little practice will not hurt you, ladies and gentlemen. All right, ladies and gentlemen, let's go through these. So looking at the first one here up at the top, ladies and gentlemen, Na, what's its charge, Mariana? What? When it's alone over here. Nope. When it's alone, it's neutral, yes. When it's alone, it has a charge of 0, okay? So then what do we know about the bromine here, Zoe? Right here.
It's also 0.
It is also 0. But now in the compound over here, Faith, what is the charge of Na? Positive 1. What's the charge of the bromine here, Alex? Well, where's bromine on your periodic table, Alex? Okay, look above group 17. What's the charge? -1. Okay. So once we know what group it's in, we can figure out what charge it is. Very good. Okay. All right. Now we go to this next one. Zinc. What is the charge on zinc, Brianna? Right here, zinc. 0. Yes, because it's alone, it has a charge of 0. All right. Christian, the charge of hydrogen right here. What is it? +1. Very good. It's in group 1. How about the charge of bromine here, Kayana? -1. All right. The charge of zinc here. What is that, Helen? Now, for zinc, if you're looking up there, Helen, you might be in trouble. Because for zinc, hang on. For zinc, ooh, that's a lot small. I guess we either get really big or really small. Let's do this. Wow, that's not helping you. All right, let's go back here then. Boom. Okay, find zinc number 30 on here, Helen. Okay, so what charge is it? Yes, +2. Okay, +2, thank you. All right, so this was 0, this was 0, this was +1, this was -1. This is 0, this was +1, this is -1, this is +2. All right, what's the charge of bromine here, Victoria? In this compound, what's the charge of bromine?
-1.
-1. All right, what's the charge of hydrogen here, Jaslyn? I'm sorry? 0, correct. Because it's alone, it has a charge of 0. Lucy, what's the charge of Fe over here? When it's alone, it's a 0. Very good. All right, what about the charge of hydrogen here, Christopher? +1. All right, what's the charge of the chlorine here? Go ahead, Kevin. -1. Now I'll help you out with the charge of iron here. Because chlorine is a -1, and there's 3 of them. This iron is a +3 over here, ladies and gentlemen. Okay, so now what is the charge of the chlorine here when it is alone here, or I'm sorry, in this compound? What is the charge of the chlorine, Mariana? -1, very good. And what is the charge of the hydrogen here, Alex? 0. Okay, good, 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 good. One more to go. Okay, what's confusing you, Jaslyn? Okay, because I thought, maybe I heard you wrong, but I thought you just said you were lost.
Yeah, but I can do it help.
Okay, so where we're getting these things from, ladies and gentlemen, is your charges on the periodic table. The only one that I didn't get from the periodic table was the iron that I did. Christopher.
So it doesn't matter how much there is of one element.
No, it doesn't. Not for their charge. For iron, though, it kind of does. Here's what I mean by that. We can't find the charge of iron based on where it's at on the periodic table. It's in an area where it could be more than one charge. So for that, ladies and gentlemen, we kind of need to work backwards. Here, ladies, stop. There you go. This is what we're working on. I think there might be more than one there. I'll take the extra one back. Thank you. Okay. Because we can't tell the charge on iron here, now it does matter, and this is what we showed you last week. There are 3 chlorines, and we know that every chlorine is a -1. That we know for sure. Negative charges, nonmetals do not change their charge. So that means this has to be a total charge of -3. The total charge on a compound always has to be 0. So we need some number to balance off this -3. What numbers balances off a -3? A +3. Now, in here, there is only one iron, which means what number times 1 gives us a +3? +3. That's where I got this number here from. Okay? Otherwise, everything else, we've just looked it up on the periodic table. Okay? Now, again, 0, 0, 0, 0, 0, 0. Why? Because these are all alone. They are not with something else. When something is alone, its charge is always 0. Okay? So unless it's combined with some other element, it will have a charge of 0. When it does combine, then we go to the periodic table and we look at the charges that are up there. So for sodium, here it is, it's a +1. For bromine, here it is, it's a -1. For hydrogen, it's right here, it's a +1. For bromine, it's still a -1. For zinc, again, this is one that was more difficult, but again, at one point in time, I had you write down by zinc that it was a +2 charge when you put the charges on your periodic table. So that one should have been on your periodic table. And again, bromine is a -1. Again, iron alone is 0. Hydrogen is a +1. Chlorine is a -1. Iron, I showed you how that it's a +3 right here. Chlorine is a -1. Questions? Okay. Now, we'll get to the last one in a minute. I can't go down there quite yet, ladies and gentlemen, because if I do, I'm going to lose all this writing that we have done. So what we're now looking at, ladies and gentlemen, is what the charge is like before the arrow and after. So this goes from 0 to +1. That's a change. That means this is either oxidized or reduced. However, the bromine goes from 0 to -1. So this is becoming more negative, and the other one is becoming more positive. And that's what happens in redox. One becomes more positive and one becomes more negative. Down here, zinc goes from 0 to a +2. It is becoming positive. All right. Hydrogen is going from +1 to 0. That is becoming more negative. From +1 down to 0 is more negative. But also, ladies and gentlemen, bromine is going from -1 to -1. So what does that mean?
Neutral.
No change. Triangle means change, remember. So no change. So in this one reaction, you have something that is becoming more positive, you have something that is becoming more negative, and you have something that is not changing. Okay? And that is absolutely 100% possible. Questions? Okay, let's get through the last one. Okay? So in the last one, ladies and gentlemen, iron goes from a 0 to a +3. It is becoming more positive. Hydrogen is going from a +1 to a 0. It is becoming more negative. And chlorine has no change. It's not changing. That's fine. Okay? Now, anything that becomes more positive, if you become more positive, it is because you are losing electrons. Which means, ladies and gentlemen, which one is that? Oxidation or reduction when you lose electrons?
Oxidation.
That is oxidation. So, sodium, zinc, iron are all undergoing oxidation. All of them. Now, if you become more negative, ladies and gentlemen, it is because you have gained electrons. And that is called reduction. So, the reduction here is hydrogen. The reduction here is hydrogen. The reduction here, bromine. Okay? So, we have identified what is being oxidized and what is being reduced in every reaction. And the things that don't change, don't do either. They're none. Questions? Yes?
May I borrow a colored pen so I can write it down?
Can you borrow a colored pen? What color are you looking for?
Something that's not blue or black.
Go. Okay. All right, so we've got one more to kind of look at, ladies and gentlemen. And that is this one. Oops, sorry. All right. So, let's start out with charges. What is the charge of zinc over here, ladies and gentlemen? What's the charge of zinc in a compound always? In a compound. +2. What is the charge of oxygen in a compound? -2. What is the charge of sodium in a compound? What's the charge of chlorine? What's the charge of zinc in a compound over here? What is the charge of chlorine? What is the charge of sodium in a compound? And the charge of oxygen? So what do you notice here, ladies and gentlemen?
Positive, negative, positive, negative.
No, look more closely.
Oh, go. Cancel.
What do you mean they're all the same charges, Christopher? Because I think you're right, but I just, what do you mean by that? Okay. What do you notice about zinc on this side?
It's neutral.
No, it's not, Zoe. Where do you see anything here that's neutral?
Oh.
But what do you notice about zinc's charge here? What is it over here? So what does that mean? It's not changing, correct? How about oxygen here to over here? Doesn't change. How about sodium? And chlorine? So what's oxidized here and what's reduced? What? This is not a redox reaction. Not every reaction in the world is reduction and oxidation. Many are. Most are. This is an example of something that is not redox. And the reason it is not redox is because nothing is changing charges. They may be changing what they're with. Here zinc and oxygen are together. Here sodium and chlorine. They're changing what's together. But what's not changing is their charges. Their charges are the same on both sides of the reaction. So this reaction, ladies and gentlemen, is not redox. Not redox. Okay? Not every reaction is. Questions? Okay. Now, we said the top three were redox. The bottom one was not. What do you notice about the top three that you don't find in the bottom one? What? Yes. You do not find any lone elements in the bottom one. Lone elements here and here. Lone elements here and here. Lone elements here and here. Without those lone elements, things are not changing their charges. Okay? When things are combined, their charges normally do not change. There might be a few very special, very rare exceptions. We won't get into those. Okay? Questions? All right. If you would, ladies and gentlemen, take and open up your EISN and get to slide number 31 so we can show you what you're going to do in the lab today. All right.
Enemy computer.
What did you do this weekend, Mr. Ray?
A lot of yard work.
Enemy dumb computer.
What's the matter, Zoe?
Enemy computer.
I still can't understand what you're saying.
Like, kidding me, computer, it.
Our computer's not cooperating with her.
Oh.
No, and it's saying ARC app launched isn't responding.
Okay, well, then here's what you do, Zoe. You go down to the library and they take a look at it and they will fix it for you.
Or you're turning your computer off and turn it on.
Yeah, did you turn it off and start it up again?
It's like keeps freezing.
Go to the go and shut it down and then start it back up again. Can you do that? If that doesn't work, we will send you to the library. Okay? All right. So here we go, ladies and gentlemen. You are going to do three different things back at the lab station. The far end of the lab is station 1, the middle is station 2, and the one closest to you is station 3. There are 2 setups on each side of the station, so plenty of room for you and your partner to work and get this done. Station number 1, ladies and gentlemen, you are going to be burning some magnesium ribbon. Now, one of the things about burning magnesium ribbon, ladies and gentlemen, is magnesium ribbon burns incredibly bright, and you should not stare directly at it while it is burning, because if you do, it will be like looking into the sun. Okay? And you do not want to do that. There are goggles on the back station on the box in the middle so that when you go in back, you can go ahead and grab a pair. When you get to the magnesium station, ladies and gentlemen, you will find a dish with a cover there that looks like this. Okay? Not like that. Like this. Okay? Now, oh, not pause. Okay? Now, you will also at your station, ladies and gentlemen, find a weighing boat that has pieces of magnesium ribbon in it. Okay? So the first thing that you are going to do is you're going to go up to one of the balances. You're going to make sure that it is zeroed, reading 0.000. You're going to take this magnesium ribbon, you're going to put it in the container, you're going to put the lid on it, you're going to take this over to your balance, and you're going to find the mass, and you are going to record it right in there, ladies and gentlemen, in that top box. Okay? So you're going to put it in front here. You want the mass of the dish, the cover, and the magnesium before you burn it. Questions? Now, What you're then going to do, ladies and gentlemen, is you're going to take the magnesium ribbon and your partner is going to hold it with a pair of tongs. Okay? Faith, come here, please. Hold that. Put those goggles on first, and then hold that. Thank you, Faith. Okay?
Someone has a big head.
Hey. Those are, just go grab a different pair then, because you're killing the ones that Miss Tracy's going to use in just a minute.
It's all right. I can readjust.
All right, so you're just going to hold that, okay, right by the dish here. Your partner is going to take a match and they're going to light it. Now, when the magnesium ribbon starts to burn, ladies and gentlemen, Faith is going to drop it into the dish. I'm going to take this cover and put it on it. So can you kind of stand on the side a little bit, Faith? Ready? You'll know when it starts burning. Yep, that's not it. Yes, when it starts to burn really bright, drop it. Okay? You ready? Good. Here we go. Change of plans, ladies and gentlemen. I will pull out the Bunsen burners for you. I'm good, Faith. Thank you. Yep, give those to Miss Tracy, please. Okay? Now, if you're working with Bunsen burners, remember, ladies and gentlemen, safety first. Ladies, gentlemen, if you have long hair, there are hair ties in the back in the middle station. You can grab one to tie it up. If you have a sweatshirt with dangling strings on it, tuck them inside. If you're wearing your lanyards, please take them off. Why? We don't want anything near the flame that will catch. So I'll pull out a Bunsen burner for you at your station, ladies and gentlemen. To light your Bunsen burner, you turn on the gas, you come from the side up, move away from the Bunsen burner when you blow out the match. I've seen people light it like this, blow out the match and blow out the Bunsen burner at the same time. Okay? So, this will for sure get us burning with the magnesium ribbon. So I'm going to hold the ribbon right near the Bunsen burner, put the container right here. I'm going to actually hold the top, put it into the Bunsen burner. Now we get a nice bright flame. Now we get it burning, and now we let it go in there. Now I did not put the cover completely on it. Where are you at? Sure, by the time I get there, it's all over. I did not put the cover completely on it, ladies and gentlemen. I left an air gap on the side. Why? So that it'll burn as much as it can. But I also don't want to lose things going up into the atmosphere. So I put the cover on there because it's hard to see, but the cover actually caught some of the residue that was created. Okay? And I want that because now I'm going to go and I'm going to find the mass. Now, there's a lot of magnesium ribbon there that is left unburned. I'll shut off the Bunsen burner now. Okay? There's a bunch of magnesium ribbon in there that is left unburned. That is fine. That is fine. Okay? Now I'm going to take this back over to the balance. I'm going to find the mass again, ladies and gentlemen. I'm going to find the mass again. So, you're going to record the new mass of the magnesium ribbon, the cover, and the dish after burning. You're going to take and tell me what happened to the mass. Well, there's only 3 things that can happen to the mass. What are they?
Increase, decrease, or stay the same.
Thank you. So, tell me what happened by comparing your numbers, and then give me a possible reason why your numbers did what they did. If they stayed the same, how is that possible? If they went up, how is that possible? If they went down, how is that possible? Give me a possible explanation for it. Okay? Questions? All right. All right. For our next one, ladies and gentlemen, in the middle station, the Bunsen burners are already out there. There are pieces of copper metal in a dish at your station. You're going to take that copper metal, and again, you are going to find the mass of it before you burn it. So again, in here, you're going to record the mass of it. Then you are going to burn it in a flame for about 2 or 3 minutes. See what happens to it, and then you are going to record the mass after burning. Now, this is going to be extremely hot after being in the flame for 2 or 3 minutes. Do not immediately put it on the balance. You will ruin the electronics in the balance if you do that. So, again, what you are going to do, you're going to start your Bunsen burner. By the way, where have I been putting all my used matches? In the can that is at your station, so please continue to do that. Turn on your gas, light your match, from the side, come up, move the match away, blow it out. Put it in the can. Now, you're going to take your piece of copper metal, and the hottest part of the flame, ladies and gentlemen, the hottest part of the flame is that inner blue cone right in this area here. You're going to hold that copper metal over that and move it around both sides for about 2 to 3 minutes. Just move it in there back and forth, recording what you see happening, making observations of it. You don't have to write them down, but you're making observations of it. When you are done, ladies and gentlemen, do not go over to the balance and throw this on the balance. Shut your Bunsen burner off. Set this at your station for a few minutes. It will not take long for the copper to cool down, but if you don't let it cool down, as I said, when you put it on the balance, you will ruin the pan and you will ruin the balance, and that's about a $1,200 balance. Okay? So let it cool down, let it sit. Then you're going to take, and again, when it is cool enough that you can pick it up with your hand, you're going to go and you're going to put it on there. And right now, it's not quite that cool. So give it a little longer than that. Okay? Again, no hurry. Questions?
Do we want it in the bowl?
No, because you don't have a bowl there for this station.
Okay.
For that station, it's just the piece they're sitting in here. Do not put it back into here because, number one, you won't know which one is yours. And number two, you will melt this tray. Okay? I will put out a dish in the middle here where you can put your used magnesium and you can put your used copper.
Okay.
Fair enough?
Mm-hmm.
Okay? So when you're done, you'll take the magnesium ribbon and you'll put it in there. Take this lid, rinse it in the sink, dry it off, leave it sitting there for the next group. Again, I will have a place for you to put your magnesium ribbon, and just don't put it back in the tray. I will put it out in the middle here, and then just rinse this so that you're getting rid of any residue that was left in here. Dry it out, and that way it's good to go for the next group that still has to work at that station today. Questions? And again, what happened to the mass, and explain why. Okay? Only 3 things can happen. Go up, go down, or stay the same, correct? Okay. All right. Now, the last one is a little bit more work to do. Okay? So, you're going to start out by filling a test tube a third of the way with peroxide. So at the station, with the lid on it, there is a bottle of peroxide. Please, please, please do not lift the bottle by the lid. I had a student in my last class the other day who decided they were going to move the bottle, so they picked it up by the lid, and guess what? The lid came up, the bottle didn't, it cracked on it. Okay? So please, the lid is just on there loosely to keep the peroxide covered. So what you're going to do is at your station, now there are multiple test tubes there. Why? Because there's different classes that are going to be doing this all day long, and there's enough test tubes for the entire day. So you're going to take and fill up a test tube about a third to a half of the way up with peroxide. Okay? And then, ladies and gentlemen, you're going to make observations. So what do you smell? You can reach in there and touch it, all those things. Okay? So you're going to make some observations of the peroxide. There is also at your station a tray that has what is called manganese dioxide. It is a silvery blackish powder. Again, you could make observations. If you want to touch it, that is fine. But when you are done, please make sure you rinse your hands. Okay? And what you're going to do is you're going to then take and just get a small scoopful onto the scoop. Just like that, ladies and gentlemen. About that much. And you are going to add it to the peroxide. And when you do, you will see things happening. And you're going to write down what you see, what you hear, all of those kind of things. Okay? And you're going to let that go for a couple of minutes, ladies and gentlemen. Okay? Now, it's very important that you let it go for a couple of minutes because of what we are going to do next. Okay. So now, ladies and gentlemen, while that is going on, you're making observations of what happened when you put the two of them together. Okay? So here are the observations of the two of them put together. This was the observations of the peroxide and the manganese separately, about 3 things of each. And then when you put the two together, what you see, what you hear, do not taste, do not touch that now. Okay? So rely on your other observations. You're going to light a splint with a match and blow out the wood splint. And then you're going to place it into the test tube where this is going on. So after I light this and blow it out, I'm going to take it, I'm going to put it down in there. I am not trying to get this into the liquid. I'm just putting it in there to see what happens. But what we have to put in is what is called a glowing splint. And let me show you how we get that. You take a match, you light it, then you light the splint on fire. Blow out the match, and then that is a glowing splint. Does everybody see that? Mm-hmm. Okay. Now you're going to stick that into the test tube. Down into the bottom, not so that you are getting it wet, but just so that you are getting it in there, and you are going to see what happens. Okay? When you're done with this splint, throw it in the container with all of the matches. This, ladies and gentlemen, can then go down the drain. Rinse it with plenty of water, the drain and the test tube. And then I'm going to take the test tube and I'm going to put it upside down in the rack to let people know I use this and to let them know that it is wet. So I just rinse it a few times, ladies and gentlemen. Down the drain, plenty of water. And then leave it there like that. And there should be plenty of test tubes for people to do their experiment with without having to use that one. Questions? Okay. That's perfect. That makes 16. That makes 8 groups, ladies and gentlemen. So you have got 25 minutes to get 3 stations done and to make your observations. Everything you need is out and back except for at the far station, I need to put out a couple Bunsen burners for you. I will do that right now as you're heading back there to go get to work. Partner up, 2 people per group, ladies and gentlemen, and let's get to work. Remember to grab your goggles out of the box. Remember to grab a hair tie if you need it, please. Yes.
So for this one,
Did we what?
the bottom one, like the positive.
Well, what we found is that nothing became more positive and nothing became more negative. Same charges on both sides for everything. Yeah, and so does this one have a negative one. I don't care about the numbers down below. All I care about is the charges.
I thought NA was the 3N, so that's what it was.
Everything's staying the exact same charge, so we didn't change anything. Okay? You can start at whatever station you want, but please remember, whatever station you start at, ladies and gentlemen, Make sure you are writing your stuff down for that station, please. For that station, make sure you are writing your stuff down. I will be there in a minute to put out your Bunsen burners for you guys, Jaslyn, Brianna, Victoria, and Jennifer. I'll put out a Bunsen burner for you in just 1 second. It will not catch fire just from the match.
She goes to pay for it. She tapped her.
Yes. Everything all together before, everything all together after. Including the zinc. You want the zinc in there because we want to see how it all changes. Okay? So that's what we're looking for. How does it all change during this experiment? Does it change? Okay? And you guys can share the Bunsen burner, whoever's using it, just use it and shut it off into the other one. Okay? Good point. Goggles. What? Something we don't understand or? What? You don't get injured. That's great that you're willing to take that chance, but unfortunately, if you do, your parents are going to sue me, and I'm not willing to take that chance. And I can't go to, well, he said he never gets injured. Okay, your parent, your guardian, someone legally responsible for you because you are not at an age where you can be legally responsible for yourself. So, again, I'm not protecting you, I'm protecting me.
Mr. Brandon,
This is scary. I still like it.
Are y'all done?
Yeah.
Yep. Go down there.
Heck yeah!
Plenty of water though too. Okay, make sure the water's running. Okay. The gas jet over there, when that valve is running the same way, or if the handle is running the same way as the valve below it, it will be on. If you guys are ready right after they go here, you set yours and then you use it both at once and then just turn it off by turning it 90 degrees.
it smells like burnt hair.
Put them on and leave them on. Either that or you can go sit down. You don't have to do this. Wait. Okay. Next time. You guys will try to stick it in there. Trust me, if you just come up gently from the side, it'll work really easy. Higher, higher, higher. There you go. Put it in the tray. Put the cover on. There you go. Very good.
See, if you stick your hand in
You want to take a look at the customer over there?
if you catch on fire. I got time.
Only have it
You just watch the car that we live. It's 820.
I wish we had
Also,
Mr. Brandon, I want you to go fast enough to put the lid on it.
well, I guess we're gonna see. Aren't we? The best we can do is what we did and go for it. So. Did you get the part about me saying that the hottest part of the flame was the top of the cone up there and holding it right over the bottom part of it? So right in there.
so when you cook something, you place it on top of the
Well, there's a hot part of the fire and there's a hottest part of the flame. See this for a second? And do exactly what he's doing, just move it around in this way. And up at the top of that,
He's doing that thing from YouTube.
Yeah, right around there. You can leave it there for a few seconds and then just move it around when it starts to see something's happening. How long did you do it? See. Yeah, I think you're pretty good too. Set it on the counter. Sit there for now. Write it down on the counter. Turn off your Bunsen burner. And now you can let it sit for a couple of minutes. The copper is at the next station, so you gotta move to a different station to do the next one. You can go to station 3, or you can go to station 2, whichever one is open. Okay? Your copper pieces, when you are done with them, after you have found their mass, go in here. Your magnesium pieces, the ones that are left over, go in here.
Did you do it for 3 or 4 minutes? Like, that doesn't look good. Put it further in the flame. Like, you need to be in that blue part of the flame. See this blue part down here? That's where you need to be. Yeah.
Leave it upstairs on higher under top of that inner blue foam. That's the hottest part that will make you go this way. Once you're done and cleaned up, ladies and gentlemen, you can move to another station. You have 2 more to get done. What? Whichever one you want, whichever one is open.
Where's copper?
You're not at the copper station, Victoria. You're now at station 3. So skip that one and go to 3 because that way you can do that one because the other ones are busy, okay? You're welcome.
Oh, what did you do with yours? The magnesium over there. And then you just rinse it out. And then you should have got half.
It was just a number of them around. It was just about 1 year ago, my parents let me grow my hair a little bit, and I used to come along with
So you can take it out and just set it on the counter for a little bit. Turn off your Bunsen burner and now wait a couple minutes for it to cool down. I don't think I have them for that one. I'm not sure.
I was thinking about one time to make sure they make 18 or 15 hours.
If you stay on the same side, there's something that's
That one go
My
for it.
boyfriend is about to be $19 an hour. He works 10 hours a day. What does he work? Hey!
Oh, that's not peroxide. This is. Okay, so that's the stuff you use, not water. Thank you. And the top. Put it all in there, find the mass. When you're done, you're going to put it all in there and find the mass again. Okay, let's go. You can go either way. Either way. You're at demo 1, but you're not at demo 3. Do the explanation part. Again, you can get all your results and then you can go back and do the explanation afterwards. But you need to do both parts.
Mr. Burnham, how does it take to stop?
Probably won't. Did you do the experiment? Did you like the split and do that part yet?
No.
I could probably do that anytime now.
And then, oh, and then he was saying that. And he was like, well, you better go back. That's why it's
Don't put the lid on very tight. All I wanted to say is you stay on the table. Because otherwise someone will spill it thinking about it.
we got all pies.
You gotta add the manganese dioxide.
It's just like,
Yeah.
Oh, sorry. I'm in Mr. Gray and I told him to go
Your cover is not on there. Oh wait, it was underneath. Okay, sorry. You can do it that way though. I didn't see it underneath. Thank you.
is this one right, teacher?
What? That's the peroxide. Yes.
Mr. Braylon, the only thing that the split did was it made the smoke stop.
Really? That's the only thing that happened?
Yeah.
That's I guess what you're right now. Yes.
You literally did.
And it made it dark. Wait, how many observations?
Good rule is always 3.
Made it darker. And
You've got about 9 minutes to get your last station done, ladies and gentlemen. Well, you're on your second one right now. Get it done.
yeah. It's hot. It's warm.
As soon as they're done lighting it, you can light it, yes.
It's warm. Feel it.
Oh, what it? Snow?
No, tell them the truth. It is very bright light. It's not very bright light.
I'm scared, bro. Can you help me? As soon as I put it in, put it down. But don't cover this completely.
Come on, dude. They're waiting for you to get done so they can do theirs. So let's go. You guys be ready? Where's the hottest part of the flame? Okay, then you guys use it to light yours and get yours done. And there. And then wash it out. So light the remaining piece in there. Okay, now take it out. Blow it out.
You said
I'll do it again.
this, right?
There you go.
People, and then Bethel's mom.
Okay, now blow it out. You're good. Record what you saw and put it on one of the spikes. There you go. Perfect. Thank you.
Mr. Moon, we just put this on the scale.
Yep. Burn it for a couple minutes and then find the mass again before the end of the hour. Nothing's gonna explode. You'll be fine. If you die, we'll have somebody replace you tomorrow.
Wow.
Yeah.
Just dump it in the
What?
I should just dump.
Just dip it in.
Did you finish all three?
You just said
No, that one, and then this one. You all three. I thought you should have two done about that at that point. Finish your third one.
I don't know.
Same way you turned the last one on. Pull it towards the left.
Wait.
Whenever you put it so that it's on the top of the jet coming up, that's on. Whenever it's 90-degree angle to it, it's off.
Okay, so what's happening?
You
guys do. Okay. So just put it in the thing so that you can do it.
Okay, there you go. You destroyed it. Why are you using
You
another
don't
one?
need another one.
Let's say you could have used that one if you wanted to.
You make your observations.
What?
It's your third one. You have
Couple minutes.
Somehow we need to get this
4 minutes. 6 minutes.
The third one, you mean? That's the first. The third. Okay, they're finishing up there. Okay. There's a group that's finishing up there. As soon as they're done, you can move into their spot.
I'm not gonna say it out loud to Mr. Burns.
For what, Jaslyn?
For a word I was gonna say.
Okay, good. At least you have these good sentence. Now, slow down. Slow down. Hold it right in the flame. Down a little, down right there. Just hold it in there, just move it back and forth. You cannot take it out of the flame. How long has it been going? I would say 2 to 3 minutes.
Halfway.
When you get it, cap back on. Set it on top like that. Only because I don't want somebody pulling it off. Right. No, not a problem. That's why I'm letting you know. You may want to write those down. That would give you time before you go and have to write your splinter.
Oh, there's no. Let me just see. I did for 2. Wait, like right here.
It doesn't take a lot of them. About half of that. There you go.
And
There you go.
so there's no.
Now you guys can not share the observations. Now you can go ahead and do it.
I feel like that's too low.
No, I think this is too much. I'm not.
Not in the water!
Just in the test tube.
Dude, do you even pay attention?
Yes, I messed up one time. You go down, dang.
Well, what if that liquid was flammable?
It
Yeah, and you know that how before you dig your thing in there.
Chris, you watch Breaking Bad. Walter threw down the rock and the whole place exploded. Like, no, this isn't crystal metal.
Yeah,
I was rewatching.
I don't know, she told me it was good, so I just.
Sometimes you don't get to make mistakes in life.
What's happened when you grow? Remember I made that little mistake.
No, I cannot. It is your experiment. It is your lab. And just get close to it and see if you can feel if it's hot. Turn off your Bunsen burner since no one's using it. Thank you, Jeff. No, I understand, but now that they're done, make sure you turn it off. Are you good? Kevin, are you trying to protect the top of your hair right there? Or? Okay. You've got 4 minutes left to get finished, ladies and gentlemen. 4 minutes left to get finished.
If it's too hot for you to touch, just when he doesn't want it.
That's hot. That's hot.
Again, maybe try just touching it gently instead of trying to stick it on. Here's the other thing. You see all that stuff that you're losing
Put it
there?
right in the
We need to find an answer.
It's okay, I'll screw it back on there. Like mine, put it right in there.
You're right, it doesn't feel hot until you touch it. That's why you just touch it very quickly. You don't grab it, because when you grab it, then you got it in your hand.
You just by tapping it. That's the time.
Hold it higher up. Take it out of the flame, but hold it back more gently. That's like that. Same thing, Mario.
Yeah, I did.
Pour it down, pour it down.
No, she was
Really? It's like a weird smell. That could be me in general, but it smells like that. Me, it kind of smells like a small.
Swatted out the air.
Why? I thought it did. That way I just so it smells like a small.
See, that's what That's because you have the copper portion of it. I'm not really. I try to hold that. I just like to believe I'm shooting shots. But my cord.
2 minutes, ladies and gentlemen. 2 minutes to get done and get ready to leave. Set them off because you gotta have time for them to cool. Take it off, take it off, take it off. Put it on its table. What?
Are you
Right, well, that's what you can start with tomorrow.
If you were a pony, you'd be a donkey.
This is my neighbor's
Because you
Yeah.
guys,
That's
because
why.
you guys are. You guys will do this.
Was it hard to climb out?
How hot was that when you picked it up like that? Right, because hot things don't affect you real quick. Well, it's hard to tell when it's all the way off. It literally stops. I always check it.
I don't care.
Believe me, Jocelyn, it's not.
I believe I have access to a shower.
Use that, bro.
7.913.
Taper was nice. I was so normal with the taper.
It's ready. I'm gonna get some breaking stuff.
Have a great day, ladies and gentlemen. We'll see you tomorrow.
are you talking about?
Goodbye, goodbye, goodbye.
I feel like Jesus Keeper's gonna see my grade and yell at me.
Kevin, come on.
Have a good day,
I
Zoe.
can't tell Kevin to hold on to the phone.
Well, you did. Don't worry about that. Kevin knows.